Well, good evening, students. It's Mr. Rich. It is Sunday, February 2nd. We're doing another Mr. Rich Q&A with your math homework questions. I've got a number of students here, and I see a few questions coming in. I got questions that came in from Joe on the SAT. I can work some of those. Looks like Bella and Izzy have submitted a few things. Reagan was asking whoever AC style questions. If you have any, sure, we can do some AC questions. I would say, Reagan, if you've got some in particular, maybe send those over. Like if you've got an ACT practice test. I mean, I got tons of questions I could just pull out of the air, but I got hard, I got easy, but definitely just snap a photo of one and drop it into the chat or send it to me at askmrrich@gmail.com. All right, let me start off. So again, if you've got any homework questions, right, every week, if you come here, you can just watch and see what questions I'm working for other students, but feel free to take a photograph of what you've got and drop it to me in the chat here or email. So like Izzy and Bella, they can drop photos right in here, and then I can copy them over to the whiteboard and we can take a look at them. All right, so so this question that I'm gonna work here from Izzy, this one is an AP Calc question. I think it's either AP Classroom or Delta Math. Give me a sec and I will have it pulled up. So if you're here for AP Precalc or Algebra 2, and you're not an AP Calc student, you're probably not going to find it too interesting when I do a Calc question, but send your question in and I'll get to it. So the first question here, sharing my screen, I think that would be a good idea. Okay. This question says, let G be a differentiable function so that G of 4 is 0.325 and G prime of 1 over x e to the minus x cosine of x over 100. What is the value of G of 1? So Izzy and Bella, this right here requires us to integrate. So what I'm going to do is I'm going to integrate the G prime. Notice this is a calculator active. So I'm going to integrate G prime. So I will be putting that into my function on the calculator. Now, what are my limits of integration? Well, what I want to do is I want to integrate from the x value at which I know the y value. So I'm going to integrate from 4, and then I'm going to integrate to 1, like that. Because this gives me the net change of the function between 4 and 1. So that allows me then to start at a y value of 0.325 and add the net change from that x value of 4 to 1. Now, it doesn't matter that I'm integrating backwards here from 4 to 1. That's okay. The math is going to take care of itself. So I'm going to go into my y equals, and I'm going to put this G prime function in. So I've got 1 over x, and then that's going to be multiplied by e to the negative x, which is also multiplied, put parentheses there, by cosine of fraction x over 100. So kind of a nasty function here. So then you double check to make sure you put that in there just like it is. 1 over x e to the minus x times cosine x over 100. That looks good. I also need to check that I am in radians mode, or else my answer will be garbage. I am in radians mode. So on my home screen, I'm going to go straight away 0.325 plus math 9, integrating from 4 to 1. And then I'm going to blow in y1, alpha trace y1 dx. And now I'm going to hit that button. And if I don't see one of those 4 numbers there, we're in trouble. Okay, so I like A, like that. Okay, so again, integrate your derivative function from the known x value to the x value at which you're trying to find the value of the function. And then add to that the initial value, 0.325 at that value of x right there. All right, hope that helps. And I've got some other things. So Bella and Izzy are sending calc questions. So those of you that don't want to be looking at calc all night, send me some questions. I'm going to go to a few SAT questions that were submitted. I have not seen these in advance, Joe. I think you said these were some other practice tests that you were working, but see if I can find them here. Okay, looks like Taylor sent in something. I'm just going to pick one of these at random here. Joe, I'm not sure I can even read that. Let me try to copy it over. Okay. All right. This is what Joe says, or not Joe, but the SAT question says x squared minus 12x plus 7 is 0. One solution to the given equation can be written as j minus the square root of k, where j and k are constants. What's the value of jk? LOL? I don't know. I don't know who wrote that question, but LOL. Oh, what is the value of just kidding? Okay, I don't know. Well, that would be, I suppose that would be just a quadratic formula question to solve that, because it's talking about solutions. So that would be 12, right? Negative b plus or minus the square root of b squared, 144, minus 4 times 1 times 7, all over 2a, all over 2 times 1. Okay, so that would be inside the radical is 144 minus 28. I could have done that in my head, but not if I type it in wrong. 116. So 12 plus or minus square root 116. That can be simplified. That's divisible by 4 for sure. Yeah. So that's 12 plus or minus 2 root 29 all over 2, which would then be 6 plus or minus root 29. So that means that j must be 6 and k must be 29. So Joe, I think the answer there would be 174. If it's not right, then I don't know what to tell you. All right, next I've got one from Taylor. Let's see what this looks like. If the function f is defined by x cubed plus 2 and g is an antiderivative, and g is an antiderivative of f such that g of 3 is 5, then g of 1 is what? G is an okay. G is an antiderivative. G is an it's an antiderivative. I get it. Okay. Okay, so G is an antiderivative of f of x. That's what they're telling me. Such that G of 3 is 5. Then what is G of 1? This looks similar to the problem that we were looking at. G of 3 is 5. I would have to take G of 3 is 5. Okay. So then what I would do is I would say if g of x is the integral of f of t dt, so I'll use a dummy variable here. It's an antiderivative such that g of 3, so if x is 3, okay, let's see here. This function, the cube root of the square root of x cubed plus 2 has to be a function that looks something like this. And g is its antiderivative. So if you're over here at 3 and that's a 5, then g of 1, I'm not sure, Taylor. I got to think about that one. I don't know. For some reason, that one got me. Let's see what else we've got. Now, you have another one that looks maybe somewhat similar to it, but I'll try that one too. And let's put this one up here. Okay, this one wants an average rate of change. Let me take a look at the chat here. Let's see. Let's pull up the chat. Where is our chat? There we go. Move this over here. There we go. Okay. The function f is given by this integral from 1 to x of that. What is the average rate of change of f over the interval 0 to 3? Well, the definition of average rate of change of a function f is going to be this would be f of 3 minus f of 1 all over 3 minus 1, right? That's average rate of change of my function f over that interval. You have to find, this would be f of 0. That'd be 3 minus 0, because our interval is 0 to 3. So we have to do this calculation right here. So what I'm going to do is I'm going to come over here, Taylor, and I'm going to put that function, the square root function, into my y1, and we'll call it x to the third up, and then underneath the radical is a plus 2. So it's square root of x cubed plus 2. All right, I got that in there. And then I'm going to evaluate that from 1 to 3, right? F of 3 would be the integral from 1 to 3. So I'm going to put this as one fraction. On the top of my fraction, I'm going to do math number 9 and integrate from 1 to 3 of y1 alpha f4 y1 dx. And then I will take away from that another one. We're going to do math 9. This integral, though, is going to be from 1 to 0 because I'm doing f of 0. And that also would be for function y1. And then I'd be dividing that by 3. And I get 2.694. So it's going to be this one right here. Okay, average rate of change with that. Maybe that one will come to me at some point. All right, doing too much calculus here. What else do we got? I'm going to go back to SAT. I don't want to lose my students who aren't calc students here. Some of you showed up. I'm just going to pull another one of Joe's. That one looks pretty easy though, Joe. Let's see. Ooh, that one looks interesting. It's got some trigonometry in it. I don't even know. I can read it, Joe. What kind of camera you got on your phone there, Joe? Sine, I can't even read that. Sine of A to something is equal to cosine of B. I don't know what that is. Do you have it handy there, Joe? I can't read it. Well, it's got to be an A. No, because I can't tell what that exponent is. Can't tell. All right, I'm gonna go back to this is another one. This one comes from Bella. So look into that, Joe. See if you can tell me what those are. You can put them in chat. I think he answered it. Oh, it's just a degree symbol. No wonder. Okay, I'll go back to that in a sec. So Bella, this one says, let f be a differentiable function such that f of 3 is this and f prime is this. What's the value of f of 5? So again, it's going to be very similar to the one I did there for ISI. I'm going to say that f of 5 is going to be, I'm going to write it out maybe a little bit more completely than I did on ISI. So I'm going to start at f of 3, and then I'm going to add to that the net change that would occur from 3, right? Because these two are going to match right here. I know the y value at x equals 3, so then I'm going to integrate from 3 to 5. And what am I going to integrate? I'm going to integrate the f prime function like that. So I'm not even going to put this one in the calculator. You can do this. You're going to put this into y1, and then you're going to just simply put 2.345 and then add math 9 on your calculator, integrating 3 to 5 and call up y1, and then you'll get a match there. Oh, okay. Issy says, how do you put sine squared x in your calculator? That's a good question. I assume that what Issy is asking there is did that come from another problem? Maybe not, but just generally speaking, that is an issue. If you're finding, let's just suppose your function that you're trying to put into your calculator is sine squared x. You have to put it into your calculator by what it really means. It means sine x to the second power. Now, if you had a TI Inspire, one of the the latest and greatest, the big blue brick thing right here, this thing, that's an Inspire. If you're one of those, I have no doubt it'll take that notation, but not the TI-84. So you got to enter it in like this. Okay. If you're even trying to evaluate, if let's say you're trying to evaluate sine squared of pi over 3. Well, it's sine of pi over 3, the whole thing squared. That's what that notation, when you put that square right there, that's what it means. Okay. I hope that helps there, Issy. Back to Joe, he was just saying that was a degree symbol. Sine of A degrees is equal to cosine B degrees, where A and B. Why didn't I recognize that? That I should have recognized that. So the number, whoa, wait a minute. The number A is 70% greater than the number B. What's the value of A? Are you kidding me? All right, well, I'm going to write this as an equation. The number A is 70% greater than B. That would mean I would multiply B by 1.7. If something is 70% greater than, that it's 1 plus 0.7 times B, or just 1.7 times B. So are you sure this is an SAT question? I have my doubts, but that doesn't look like an open response one, because what I would do is I would substitute that in and say sine of 1.70b is equal to cosine of b. Now, what would I do with that? Yeah, I'd be solving for B and then I'd have to plug it back in down here to get the value of A. Yeah, I don't know. Any ideas here? I think I'm gonna have to use my calculator to graph both functions and see where they intersect one another. I can't think of another way to do that. No, wait a minute. Wait a minute. It's got to be an easier way. I know what that degree is. When is cosine and sine the same? That's going to be in terms of degrees. That's going to be 45 degrees, right? Yeah. Oh, I think I know. It's going to be at two places though. Oh, A and B are positive constants. Sine and cosine are the same for A is 45 degrees and A is 225 degrees. When the angles are 225, not just A, but for those two angles. Joseph, would you try and get a degree or a whole number? A is 70% greater than the number B. What is A? Sine of A is equal to cosine of B. Yeah, I don't know. My thought was to graph those two functions that I created up there, where I would say sine of this doesn't make sense because I would have to be graphing these in radians and not degrees. So sine of 45 is equal to cosine of 45. But that doesn't make any sense. I'm gonna have to think about that one too, Joe, unless you got an idea on it or if someone else has an idea. Sine of 80 degrees. Yep. I have to gotta let that one set for a while and maybe come back to it. See what else we've got here. Go back to, all right, Avery. I think Avery's got some algebra 2 or pre-calc questions. Yeah, pre-calc. All right, so let's go to do a pre-calc question. So she's already working well into unit 3, solving some trig equations. Is what she's doing. This comes from Delta Math. For all angles 0 to 360 that satisfy the equation, find all angles that satisfy the equation below to the nearest tenth of a degree. Well, what we're going to do is solve this much like a quadratic equation, but I got to get rid of the cosine squared right here. I can't have a mixture with cosine and sine. So I'm going to use my trig identity that says cosine squared is 1 minus sine squared. So I'm going to substitute 1 minus sine squared theta for cosine squared. And the equation will look like that. I'm going to distribute that minus 2 through the parentheses and get negative 2 plus 2 sine squared theta minus 3 sine theta. I'll bring that minus 1 over and call that plus 3 equals 0. I'm now ready to set this up in more of a standard form. 2 sine squared theta minus 3 sine theta, and then I'll combine the negative 2 and the plus 3 to be plus 1, like that. That is a quadratic type equation. I've got a sine squared, a sine, and then a constant. And I believe this can be factored, Avery. So I'm going to go 2 sine theta as one binomial and sine theta as the other. And I believe this is minus 1 and minus 1, like that. That would give me a negative 3 sine theta. So that means I can set both of these factors equal to 0. So one of them is sine theta is 1/2. This one gives me sine theta is equal to 1. We are only considering angles within the unit circle from 0 to 360. So the solutions for sine theta is equal to 1/2 is going to be in the first and second quadrants. So that's going to be 30 degrees and 150 degrees. Is that right? Sine 30, 1/2. Yep. 1, 2, 3. In my unit circle, 1, 2, 3, 1. Yes. So 30 and 150. And then sine theta is going to be 1 at 90 degrees. And those would be your 3 answers. You'd have 3 answers to that. They want it in degrees, which is a little bit weird. And we don't need to do tenths of a degree because those are going to be the exact values. All right, so it ended up being you had to use a trig identity here, bottom line. You had to get rid of that cosine squared with 1 minus sine squared and put it in a standard form looking like a quadratic to be factored into 2 binomials multiplied together. That's what that is. Thank you for sending that. Okay, I'm gonna do one more of Avery's since we haven't done any pre-calc except for these. All right, so this comes from also from Delta Math. and it says, solve the trigonometric identity below for the interval 0 to 2 pi. Use the interval notation to represent the solution set. So I will divide by 9 on both sides. So that means sine theta has to be greater than negative 1/2. So sine theta greater than 1/2. So I need to find the angles, okay, where sine of theta is larger than a half. Now, a couple of ways to do this. I'm going to do this on the unit circle. I'm going to draw myself a picture of the unit circle. I know that the sine values are the y coordinates, and my y coordinates where I'm going to have a negative 1/2 are going to be over at these angles here. This angle is these are in radians, right? So these angles we're going to answer have to be in radians. So this is 7 pi over 6. At that rotation, that's where I have a negative 1/2 for the y coordinate. This is 11 pi over 6. So there's, excuse me, there are two intervals here then, Avery, that we're going to say where the sine is greater than minus 1/2. I got to clear my throat. Hold on. Since the sine of an angle are the y coordinates in the unit circle, one way to do this is just say, well, all of this rotation until I get to right here, right? Because this is minus 1/2 on the y-axis. So all of those angles from all of those angles of rotation, my first interval would be from 0 to 7 pi over 6. And then once I move beyond that rotation, you can see the y values are all lower than negative 1/2. But then as soon as I get beyond my rotation of 11 pi over 6, it picks back up to be greater than negative 1/2. And then I could say that that upper limit is 2 pi. Okay. Now this is a closed interval. So I need to put a bracket here to include 0 because sine of 0 is 0 greater than negative 1/2. And then I would also put a bracket here, but this was a greater than negative 1/2. So at 11 pi over 6, sine is exactly negative 1/2. So this has to be an open interval on both of those. Okay. Now, there's another way to do it. Okay. I want to show you one other way to consider this, right? Because you want to have multiple ways to do this. When you're dealing with trig functions, we use the unit circle quite a bit, but I also find it useful to picture the sine function from 0 to 2 pi, which looks like this. So think about what this was asking us. This was, if you know that this right here, Avery, is negative 1. So here's negative 1/2. If you come over here, the sine function does not go below negative 1/2 until it's well over here into the third quadrant. And then at some point, it's going to rise above negative 1/2. And it's going to be right here. Okay, so this kind of tells you where you're looking at right here. That's why I was looking here. That right there has to be 7 pi over 6. That has to be 11 pi over 6. So all of this are sine values greater than negative 1/2, and so are these over here. I'm only excluding that region. That's where I'm down here in those third and fourth, lower portion of the third and fourth quadrants. Okay. I hope that gave you some insights on how to deal with those inequalities. Man, Joe, you got me bugged up on this one. I usually I can nail the trig ones, but for some reason my brain is just not clicking with that. It'll probably come to me like tomorrow sometime. Checking the emails again. Let's see if anything has come in. So I got Avery's. Taylor looks like she sent another one in, but let's go. What else from Bella and Issy? I think I owe Issy one here. Okay, I'll take this one here, Issy. This integration and u substitution. Yeah. Oh, I see. They did u sub. Which of the following is equivalent to that? One thing's for sure, I cannot separate integrals by multiplication. So that one is totally off the wall. I can't just separate it into this integral times this integral. That's not how integrals work. So that's out. I suppose it's possible to go ahead and distribute that root x to each of those terms, and maybe I would get that. Or should I use u substitution? Does that make sense right there? See, if I was looking at this here, and see, the reason why I don't like the u substitution is because I ordinarily would not use u substitution here. What I would do is go ahead and distribute. Now, if this was like to the power 5, that's where it would make sense to use u substitution because I would not be able to distribute that root x through the parentheses. So I really do think that I need to distribute x to the 1/2 through those parentheses. If I did that, then this would become the integral of 9 to the 7/2, right? 3 plus 1/2 would be 9 to the 7/2, x to the 7/2. Is that one of the answers there? Yeah, okay, I kind of like B. The next thing would be minus 2x, root x times root x. This would be 8x to the minus 1 when I bring the x up by the negative exponent rule. 1/2 times x to the minus 1 would be adding those exponents. I think that would be x to the minus 1/2. Let's see. Yeah, all of a sudden I am in love with answer B because I think that is equivalent right there by just distributing. U substitution didn't make much sense there. So I'm going with B, and I would be pretty confident in that answer. Okay. Here's another calculus one. Algebra 2 or pre-calc, people, send them in. We still got time. The graph of a function f shown above consists of 2 line segments and a semicircle. Let g be defined by g of x is that. The integral from 0 to x f of t dt. What's the value of g of 5? So g of 5 would be the integral from 0 to 5 of f of t dt. Well, we know that the integral of f is going to be the area under the curve from 0 to 5. So we would calculate, looks like you already did this. So we would calculate the area of this triangle from 0 to 1, and then we got to get this area from, and add that area from 1 to 5. Okay, so that is so that area is 1.5, 1/2 base times height. This is a radius of 2, so the whole circle is 4 pi, but it's half of a circle, so it's 2 pi. So 2 pi plus 1.5. That's it right there. Adding those two areas. Did I missed something? That seems too easy. No, that's it. Taylor was just trying to give me a rest there. Give me a nice, easy softball question. All right, one more. Wait, I see a couple messages came in. I sent a few. Oh, Reagan, you sent some questions in. Where'd you send them, Reagan? I don't see them. Got to send them to Ask Mr. Rich at Gmail, or I don't see them. Oh, I see them down here. I think you sent them to my other email address. No, I didn't see them. Send them again. Or did you put them in the chat? Oh, okay. I do have a college student that I tutor at 9, but he's usually late. So if you have more things for me to look at, send them in. I got time. This is from Taylor. It looks like the regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. If the area of each region is 2, what's the value when you integrate from -3 to 3? Right. So if the area of each region is 2, the area as you're integrating from left to right, the area underneath will end up being negative. So if these areas are all 2s, and as I integrate from -3 to 3, I'm accumulating going -2 plus 2 and then a -2. So that integral has to be a -2. So that's that. There's Reagan. Very good. Reagan sent some pre-calc graphing questions in. These are really good ones. I'm going to grab these. Thanks, Reagan, for sending those in. This is for the pre-calc students. If you're in the mid parts of unit 3 in pre-calc, you're graphing trig functions. So Chloe attaches a wireless sensor to one of the spokes of a bicycle wheel spinning freely on its axle. The graph below shows the sensor's height above ground in centimeters. Write an equation of y, height in centimeters above the ground, and t, time in seconds to represent the given context. Well, the first thing I always do, I don't know how your teacher tells you to do these, but the very first thing that I want to do is I want to find my midline. Okay, and the way that you find your midline is don't eyeball it. Find your maximum y value. It's obviously a 56 right here. I'll zoom in on this. and my minimum is a 14. So I'm just going to add my max and min and divide by 2, right? Because the middle line is going to be the halfway point between your highest y and your lowest y, which is the midline would be the average of those two numbers. So even if one is above the x-axis and one's below, so you got a positive and a negative number, you're still going to add them together and divide by 2 to get that average or middle value. So that's going to be 35, it looks like. So I would assume then that what they're wanting us to know, right, this thing is starting right at the midline. So this tells me that as I write a sinusoidal function, I'm going to use a sine wave. Now, a lot of times in AP Precalc, they're going to tell you write a sinusoidal function. That doesn't mean a sine wave. It could mean either sinusoidal means a sine or a cosine, depending on which one is most convenient. In this case, well, they didn't tell us they just said write an equation. So presumably we could do sine or cosine, but I'm going to do sine because sine starts right here at the midline. But here's how you write a sine function. The standard form, if you want to call it that, is a times sine of b times t minus c plus d. That's in inner parentheses right there. The a is your amplitude. Our amplitude here is the distance from the midline to the highest value. And you can take 56 minus 35, but I want to show you another way to find midlines if you need to find them quickly, and you don't maybe have the graphical picture there to jog your mind as to how you're doing the subtraction. If you take the highest and lowest values, subtract them and divide by 2. Midline is add them, divide by 2. The amplitude, the distance from the midline to the top, is you subtract the max and min and divide by 2. So 56 minus 14 would be 42. Divided by 2 is 21, which of course is the same distance as being from a 35 up to a 56. So it's 21. So I've got part of my equation. Y is equal to 21. This is a positive sign, right? It starts at the midline and it rises. If it was starting at the midline and was going down, it would be a negative sign. So it's positive 21 times sine. The coefficient b is going to be related to the period of this function. Now, it looks like from the graph, the period is exactly 7 seconds. Did they tell us that? It doesn't tell us that, but we can see that the midline right here, it's taking 7 seconds for one period, 14 seconds for two periods. So the period of this thing is 7 seconds. So that tells me that my coefficient b is 2 pi divided by 7. Right? Whatever the period is, 2 pi over that period is going to be the coefficient that you put in your equation. So this is going to be sine of 2 pi over 7. There is no horizontal shift or what we call phase shift, right? Because the sine is starting at the midline at t equals 0. So this thing has not been shifted. So this constant c inside here is a 0. So I can just call this 2 pi over 7 times t. The d is the horizontal, I should say the vertical shift. The midline has been shifted up 35 units plus 35. That right there is the function there, Reagan. That is how you do it. Okay, let's see. Where are we? New message came in. Oh, hey, Taylor. I answered that one right there, if that's the one you were asking me about. Wow, Reagan, you guys already moved on to tangent and cotangent. Okay. Okay. I'll do one of these. Find the equation of the vertical asymptotes of the trig function below in general form for all real values of x. Express your answers as a single equation in terms of k as determined by the drop box below. Well, one thing we know about the tangent function there, Reagan, is that without it being transformed, we know that the asymptotes, the vertical asymptotes, are going to fall on either side of the y-axis, a distance of the period between them. And now that's going to be true here because there is no horizontal shift. So the only thing I really need to know here is what is the period. So the period with tangent, as you probably know from your class, is the period for tangent is pi, not 2 pi. Okay, so that means then that if it's been transformed because you have a coefficient in front of the x, right? Your b right here is 1 over 8 pi. So that means period is going to be pi over b for a tangent function. So our period for this particular equation has to be by taking the period of your regular tangent function pi and dividing it by this horizontal dilation factor of 1/8 pi. That means the period is 8, right? The pi's would cancel and 1 over 1/8 is 8. So my period is 8. So that would mean then this right here is a distance of 8 between those two vertical asymptotes. All right. And so that would mean then that this occurs at a 4 and a -4. And then the next one would be at 8 at another period away at 12, like that. So I believe what you can do when you're answering this in terms of k as a single equation, your asymptotes would be a vertical line, x equals 4 plus or minus 8k. No, 12k. No, wait a minute. Yeah, 8k. Sorry. I was looking at that 12 on the x-axis and it had me confused. 8k. Right. So when k is 0, you have an asymptote at 4. When k is 1, you have an asymptote at 12. When it's 2, you have an asymptote at 20. If k is a -1, you would have an asymptote at -4. So that should be the expression for the equations of your vertical asymptotes. Okay. So one of the main things to remember about period on these trig functions, sine and cosine, their period is 2 pi. For tangent, cotangent, it's only pi. Taylor, you talking about this one? Yeah, if you're this question, oh, I'm sorry. I misread it. Oops. Now I know why you're confused. The integral is from -3. Thank you for pointing this out because I made a terrible error there. You're integrating not f of x. We're looking at f of x up here. You're integrating f of x plus 1. So what you're really evaluating is this: the integral from -3 to 3, f of x dx, plus the integral of 1 dx from -3 to 3. Well, sure, this area we figured out is 2, but this area right here, that is a rectangle, right? The integral of, well, let's just not even get into the geometry here. Well, let's do get into geometry. What we're saying here is if you go from -3 over to 3 on a function that's called y equals 1, that would be you're integrating over a rectangle. And so that area there is 6 right there. So you have to add the 6 to the 2. So hopefully 8 is one of the answers here. Oh, nuts. You got to be kidding me. What are we doing here? -3 to 3, 1 dx. And so the width is 6, the height is 1, so it has to be 6 added to the 2. Yeah. Width is 6, height is 1. So the area underneath here would be 6 added to the 2, which makes it 8, because you can split that up into 2 separate integrals. I still maintain the answer there is 8, Taylor. I'm looking to see what I'm missing on that. +2, 6 times 1. No, wait a minute. Oh, I'm sorry, Taylor. 2, right? This is -2 plus 2 minus 2. So I'm taking that net area of -2 and I'm adding that area of 6. There's my area 4 right here. I see that answer of 4 right there. Yeah, that's what it was. So don't forget, when you're integrating a constant, you are just basically taking the constant value times the width of the interval, because it'll end up being a rectangle is what you're getting the area of when you do that integration. All right, let's see what else we got. I'm going to do another pre-calc. All right, they want us to match up the equation here. Oh, I like these because we're going to use some process of elimination. The point of inflection, let's just deal with that first. It looks like the point of inflection was lowered to a -3 on all these. Oh, and by the way, these are all negative tangents, right? Because they're going in the opposite opposite direction, opposite Reagan direction. They normally tangent is going up to the right, down to the left. but these are going in the opposite direction. So all of them are negative. So we can get rid of this one because it's a positive tangent. But I do believe that I'm going to go with this answer just for the fact that it looks like these have all been moved down by 3. It's got a vertical shift of 3. Now, as far as just to confirm that that would be the period, or that would be the B value. If you look at what the period is here, the period is the distance between the asymptotes. So from negative 525 to 175, let's measure that distance. I've made so many mistakes here, mental math. Okay, so it's 350. So yeah, so if the period is 350, then your B coefficient is going to be pi over the period. So pi over 350. So definitely can't be that one. And it's definitely not moved up by 3. So yeah, there you go. I would go with that one there, Reagan. Yeah, Taylor, it was -2. That area was -2. Sometimes you can look at something so long, you just miss the obvious there. Okay, students, that takes us to 9 o'clock. I tried to answer a little bit from all the classes, although I don't think I did anything from Algebra 2 tonight. It looked like it was Calc and Precalc and SAT. So, well, I wish everyone a good week, and I will be here again next Sunday night at 8 o'clock to answer your homework questions. Feel free to send them in advance to askmrrich@gmail.com, and then I'll have them ready to go. And I'll see everybody next Sunday. Have a great week. Bye.